Hello, I'm Jiu Zhang from Sungkyunkwan University. Today I will introduce our work, fine-tuning visual autoregressive models for subject-driven generation. Subject-driven generation aims to generate new rendition of a given subject. For example, turning a few reference images of a dog into many diverse scenes. The main challenge here is preserving the subject identity while adapting to various prompts. Diffusion-based personalization produces high-quality results, but it's slow because it requires many denoising steps. On the other hand, naive fine-tuning of a VAR model is fast, but it often suffers from identity underfitting and language drift. Our goal is to achieve both speed and fidelity in the framework. Our framework ARBooth fine-tunes a VAR model through subject-driven fine-tuning. First, we encode subject images into multi-scale token maps, then fine-tune only the important layers with the subject unique token as a star. We also design a weighted cross-entropy loss to better handle identity across different scales. First, selective layer tuning. We fine-tune only cross-attention and feed-forward layers. Through our analysis, we found that these layers are most responsible for encoding subject information. By updating only CA and FFN, we can efficiently inject subject identity into the model without the cost of full fine-tuning. In this slide, we further inspect layer-wise weight differences after full fine-tuning. As shown in this bar chart, CA and FFN layers show the largest weight changes, which means they carry the most subject-relevant updates. Empirically, we also confirm this finding. When tuning only CA and FFN, the model can preserve the subject identity. Next, scale-wise weighted tuning. We observed that early coarse scales carry most of the subject identity, while later, fine scales mainly add minor local details. To reflect this, we apply a weighted cross-entropy loss that assigns larger weights to coarser scales. Our noise indexion study confirmed this. Replacing coarse scales drastically alters the output, whereas replacing fine scales barely affects the output. As a result, scale-wise weighted tuning improves both fidelity and stability of generation. Visually, without this, subject identity drifts a lot, but with scale-wise weighted tuning, the subject remains consistent. Finally, prior distillation, naive fine-tuning often causes language drift because it forgets the pre-trained class level priors. We prevent this by distilling class priors from the original pre-trained model into the fine-tuned one using a KR divergence loss. This preserves pre-trained knowledge and maintains diversity without additional data generation. As shown here, without prior distillation, the model generates diverse instances of the same subject, whereas without it, results collapse into a single overfitted loop. Here are qualitative results compared with prior methods. Our framework achieves more faithful identity preservation and accurate text alignment across different concepts and prompts. This is the second comparison. Quantitatively, we evaluate on the VICO dataset with 16 subjects and 31 prompts. Our method outperforms all baseline in both subject fidelity and text fidelity, while achieving 0.5 second inference per image, which is over 20 times faster than diffusion-based methods. In summary, our contributions are threefold. Selective layer tuning, fine-tune only CA and FFN layers for efficient personalization. Scale-wise weighted tuning emphasizes coarse scales to preserve subject identity. Prior distillation, distill class priors from the pre-trained model to prevent language drift. Together, these methods enable fast and high-fidelity subject-driven generation. To conclude, ARBooth bridges the gap between diffusion level quality and product level efficiency. Thank you for listening. Please visit our project page for more results and the source code. Thank you.